Welcome to aminacademy.com. In organic chemistry, let us discuss about organic structures. The four distinct hydrocarbon functional groups are alkanes, alkenes, alkynes and arenes. Aromatic compounds derive their names from the fact that many of these compounds in the early days of discovery were grouped because they were oils with fragrant odors. Here, look at some important functional groups. Here, alkane, alkene, alkyne and arene. Here, due to the number of bonds between carbons, it decides the functional groups of particular compounds. Due to their different molecular structure, the empirical formula of hydrocarbons is also different from each other. For instance, alkanes, alkenes and alkenes, the amount of bonded hydrogen decreases in alkanes and alkenes. This is mainly due to the self-bonding or catenation of carbon that prevents the complete saturation of the hydrocarbon by the formation of double or triple bond. Here, the catenation means bonding, self-bonding. The ability of hydrocarbons to bond to themselves is known as catenation. With such capabilities, they can form more complex molecules. Due to catenation, that it forms more complex molecules together. Like suppose cyclohexane and in rare instances aromatic hydrocarbons like benzene are formed. Cracking of hydrocarbons is a process in which the heavy organic molecules are broken down into lighter molecules. This is accomplished by supplying an adequate amount of heat and pressure. Sometimes catalysts are used to speed up the reaction. This process plays a very important role for the commercial production of diesel, fuel and gasoline. Now, how to draw a hydrocarbon structure? For example, this glycine, look at here, there are two carbon atoms and each carbon atom is 4 bonded, here also 4 bonded, and this is a functional group. Here, carbon as an element is unique in the variety of structure it can form. It is unusual because it forms strong, stable bonds to the majority of elements in the periodic table, including self also. It is this ability to form bonds to itself that leads to the variety of organic structure that exists. Chains. The simplest class of hydrocarbons, that is frameworks, contains just chains of atoms. The fatty acids we met earlier have hydrocarbons frameworks made in zigzag chains of atoms. For example, polythene is a polymer whose hydrocarbon framework consists entirely of chains of carbon atoms. Next one, the hydrocarbon is any of class of organic chemicals made up of only the elements carbon and hydrogen. The carbon atoms join together to form a framework of the compound, and the hydrogen atoms attach to them in many different configurations. Now let us discuss about some carbon chains. Here we know that this methane CH4, ethane C2H6, propane C3H6, like it goes. Here we can enlarge chain also, you can write this. Here CH4, C2H6 we can write as here CH3, CH3. Together forms C2H6. Like we can like a lengthy chain also. Now we will discuss further about the functional group alkanes and carbon chains. If you form a compound made of only carbon and hydrogen, then you have effectively made a hydrocarbon. Hydrocarbons are really at the heart of organic chemistry. They definitely are when thinking about nomenclature of organic compounds. The alkenes happens to be the most basic of all hydrocarbons. They are made up of C, a single bonded structure, and C and C is single bonded, and C and H also single bonded for alkanes. Now next, alkanes are known as saturated hydrocarbons in that all the bonds are single bond. The basic alkanes are single bonded with carbon and carbon and carbon and hydrogen. Here for general formula for alkanes is CnH2n plus 2. Suppose C is 1, here H is 2 into 1 is 2 plus 2 is 4, CH4 methane. It's a basic first of alkane group. Like the whole number given for N, it gives the different alkenes. Each carbon will have 4 single bonded and each hydrogen will have 1 single bond. Now, the straight chain alkanes are normal alkanes. This is, if you write the straight, it's a straight chain alkanes or normal alkanes. Realize that the word straight really means in a continuous line and not really straight like a meter stick or yardstick line or a football field. Just think of links in an actual chain and how the chain can be arranged in various shapes of depending on how long it is. The longer generic formula for this type of N-alkanes, suppose N-alkanes means number of each chain links. Here CH4, CH2, N and CH3. These ends with CH3 are called methyl groups. The ends with CH3 is called methyl groups. And the links CH2 are called methylene groups. This is methylene. This is the base name for which all organic compounds are named. That is, here end with CH3 called methyl group, and CH2 end with CH2 is called methylene group. You have to remember these two links. There can literally be hundreds of ways to write different structure for this same formula alkane once there are many carbons. There are only 2 possible different structure for butane. Look at butane is, for example, C4H10 is a butane, and that hexane is C6H14, next one, and has 5 different structures. Like we can write this way, like for example, nonene C9H20 has 35 different structures. Like it goes increasing different structure, you can write because of the number of hydrogen and carbon atoms increases. Here, different structure with the same empirical formula are called isomers. What is isomers? A different structure with the same empirical formula. That means we can write different way with the same empirical formula same, but we can write in different ways. Each way is called isomers. There are different types of isomers. For now, we are only thinking about structural isomers. Now look at here. Here this is dimethyl ether. Here ethanol. Here like 2 C's, and each C's are surrounded by hydrogen atoms. and once here one NC is oxygen and that is hydrogen. Now how to write N alkanes first. All those isomers will have uniquely different names, not to mention different physical and chemical properties as well. For now, just to learn the straight chain alkanes. Here these are the straight chain alkanes are methane CH4, ethane C2H6, propane C3H8, like using the formula CnH2n. CnH2n plus 2 is the general formula for the alkanes, straight alkanes. Next, a simple alkene is simply an alkane that has a carbon-carbon double bonded. If carbon is double bonded, that all is simply alkane. Alkane become alkene if C is double bonded in any one of the carbon chain positions. In order to accommodate for this, you have to remove two hydrogen. You eliminate them to use organic reaction also. This means that all simple alkenes have the generic formula CnH2n. Alkane have CnH2n plus 2, but alkene is CnH2n. Notice that there is no plus 2 on the H's. Names wise, you just replace the N suffix of the alkane with ene. That means alkane becomes alkene. Suffix for the analogous alkene, propane becomes propene, pentene. Pentane becomes pentene. Propane becomes propene, and pentane becomes pentene, like it goes. You get the idea of simple alkenes. Now just finish off the other simple types of hydrocarbons. Let's make a simple alkene now. An alkene is an alkane that has a carbon-carbon triple bond in any of this carbon chain position. In order to accommodate for this, you may to remove 4 hydrogens. Once again, you eliminate them. This means that all simple alkenes have the generic formula CnH2n minus 2. It gives alkyne group. First alkane is CnH2n plus 2, alkene is CnH2n, alkyne is CnH2n minus 2. Notice that minus 2 on the H's. Naming wise, you just replace the N suffix of the alkane with the kyne, YNE. Suffix for the analogous alkane. Propane becomes propene, pentane becomes pentene. Now, in further details, we will discuss in future videos.